Hello again, wherever you are, in the hush of night, under the weight of blankets, or just pausing between thoughts. I'm glad you're here, because tonight we're not here to learn something specific. We're here to sit with something ancient, something quiet, but impossible to ignore. A question. It doesn't shout. It doesn't demand. It whispers. It lingers. And the more we try to answer it, the more it reveals about us, not just the world we live in. What if Earth was designed? Not decorated. Not assembled like a Lego set, but shaped with structure, with intention, with care. You may already have feelings about that. Maybe you believe in a creator. Maybe you trust randomness. Maybe you don't care either way. That's okay. This isn't about proving anything. We're not drawing conclusions. We're just stepping into a space where the question lives. And we're going to move slowly, because sometimes slowing down is the only way to see what's been right in front of us all along. Start small. Don't think about galaxies or atoms. Think about your morning. You wake. You breathe. Light spills across your face. Not too bright, not too dim. You sit up, and gravity welcomes you back. You take a breath, and the air, invisible yet precise, flows into your lungs. Outside, water runs. Leaves flutter. Temperatures stay within a range you don't even notice because they're just right. How often do we stop to wonder about that? Because in the background of every ordinary moment lies something extraordinary. This world fits us. Not barely. Not awkwardly. It fits us astonishingly well. And maybe we've lived with that fit for so long that we've forgotten how remarkable it is. You see, there's a version of this world where the air burns your lungs, where ice doesn't float, where the moon never formed, where water evaporates too quickly or never arrives at all, where day and night swing between fire and frost, where DNA never settled into a spiral of meaning. But that's not our world. Our world is one where the variables, the pressure, the light, the water, the spin, all dance in a balance so fine it feels intentional. Whether or not it is, remains the question. And here's the strange part. Maybe the question is more important than the answer. Maybe just by wondering, what if this wasn't an accident? We open a door to something deeper. Not just about Earth, but about perception, meaning, and what it feels like to be a conscious creature standing on a spinning miracle. So tonight, let's walk together, through patterns and paradoxes, through biology and belief, through physics and poetry. We'll take it one step at a time, and we'll let the question walk beside us. Not for closure, but for clarity. Not to prove, but to notice. And if that noticing begins with a whisper at the edge of sleep, then maybe that's exactly the right place to begin. Let's begin by looking around. Not through telescopes, but through the lens of daily life. Through the things we often forget to marvel at, because they're always there. The sun rises. It warms but doesn't scorch. The wind stirs leaves, not lungs. Rivers carry water, not acid. The air is rich in oxygen but not too rich. We walk on ground that holds us up, but isn't too hot, too cold, or too loose. It's easy to take this for granted. Most of us do. But underneath that comfort, something hums. A quiet, nagging thought. Is this all just incredibly lucky? Science, of course, gives us answers. Earth formed from dust and gravity. The solar system spun into shape. Molecules collided. Life emerged, one adaptation at a time. It's a story told in fossils, atoms, and billions of years. But even within that story, solid and elegant as it is, there are moments where things seem just a little too convenient. Earth orbits a stable star at a distance known as the Goldilocks zone. Not too hot, not too cold, for liquid water. Water, by the way, being the exact solvent that dissolves nutrients, regulates temperature, and builds the chemistry of life. Coincidence? Maybe. But there's more. Earth's axis is tilted just enough to give us seasons, but not so much that climate becomes chaotic. Its rotation speed prevents temperature extremes. Its magnetic field shields us from deadly solar winds. Its moon stabilizes our wobble, creating predictable cycles. Its atmosphere holds the perfect blend of gases for fire to burn, plants to breathe, and animals to live. Its oceans don't boil or freeze, and their currents distribute warmth like invisible rivers of life. Each of these could have been wildly different. A small shift in any of them, and life as we know it might never have begun. Not just human life. Any life. That's where the idea of fine-tuning begins to whisper. It's not about inserting belief into science. It's about noticing how many dials are set to settings that work stunningly well. The odds seem steep. The alignment seems unlikely. Some scientists refer to this as the anthropic principle. The idea that the universe must be structured to allow life because we're here to observe it. If it weren't suited for life, we wouldn't be asking this question. And that makes sense logically. But emotionally, existentially, it feels like an answer that sidesteps the wonder. Because yes, we're here. And yes, life works. But why does it work so well? Why do all the pieces line up, not just for survival, but for harmony, balance, and even beauty? It doesn't prove anything, but it does invite us to pause. Because whether it was divine, accidental, or something else entirely, the fact that you are here on a planet that breathes with you is not a small thing. It's easy to forget. But maybe, just maybe, it was never meant to be forgotten. Let's zoom out. Imagine yourself rising. Above the trees, the clouds, the curve of Earth, until the whole planet hangs below you like a blue marble wrapped in breath. Now keep going. Past the moon, past Mars, past Saturn's shimmering rings. You drift out of the solar system into the darkness between stars. And even there, you're nowhere near the edge. Because our galaxy holds over 100 billion stars. And the universe? It may hold 2 trillion galaxies. In that ocean of possibility, how rare is Earth, really? This is the question that launched the search for exoplanets. Planets beyond our solar system. And in just a few decades, we've found thousands. Some rocky, some massive, some warm, some cold. Some in that special habitable zone where liquid water might exist. But here's the catch. None of them are quite like this one. We've found planets with no atmospheres. Others with toxic gases or extreme radiation. Some orbit unstable stars. Some spin too fast or too slow. Some are covered in gas. Some are dry, frozen, scorched, or simply too young. Over and over, Earth stands apart. Not as the only possibility, but as a startling exception. Not perfect, not singular, but remarkably well-positioned. And yet, defining rare is tricky in a universe this vast. If there are 1 trillion planets, even a 1 in a billion chance means there could still be 1,000 Earth-like worlds. Maybe more. But here's where it gets strange. Even among those, what are the chances of the right atmosphere? The right moon? The right magnetic field, geology, orbit, carbon cycle? And then, beyond all that, what are the chances of life? Complex life? Life that thinks? Life that asks questions? It's not just about a location in space. It's about a sequence, a story. And Earth's story has unfolded with an eerie precision. Not flawless, but flowing like a river that curves just enough at just the right time to reach the sea. Some call it chance. Some say inevitable. In a big enough universe, everything happens somewhere. Some say design, not in the human sense, but as a pattern with a deeper logic. And maybe we're not supposed to know which one is true. Maybe the awe lives in the ambiguity. Because here's what we do know. Out of billions of stars, in billions of galaxies, there is a small, round world. Where oceans breathe, where forests grow, where creatures wonder, and where you, just now, are listening. It's not just where Earth is in the cosmos that matters. It's also when. Because life didn't simply need a habitable place. It needed time. Not moments. Not years. Billions of years to unfold, evolve, and stabilize. Early Earth was wild. Molten. Violent. Constantly bombarded by asteroids. Volcanoes belched gas into a toxic sky. The oceans boiled, then cooled, then boiled again. Radiation from a younger, angrier sun flared without mercy. And yet, somehow, Earth endured. It didn't just survive chaos. It transitioned out of it. And that transition wasn't fast. It took hundreds of millions of years. But that patience was part of the miracle. Because for life to arise, not just as bacteria in a tide pool, but as forests, whales thought. It needed a world that stayed within a delicate range of conditions for an astonishing stretch of time. It needed a stable climate, consistent rotation, a magnetic field to shield DNA from radiation, tectonic plates to recycle nutrients, a moon to regulate seasons, rain, sun, carbon, oxygen, all in rhythms. And crucially, it needed not too many interruptions. Too many asteroid strikes? Reset. Too few volcanic emissions?
No atmosphere.
Too much solar flare activity? No ocean chemistry. Too little geologic activity? No carbon cycle. It wasn't just the presence of conditions. It was their persistence. That's where Earth stands out again. It wasn't the only place to get the right ingredients. It may not even be the only place where life began. But it's one of the few, perhaps the only we know of, that held those conditions long enough for complexity to catch its breath. And that calm wasn't passive. It was dynamic. It adjusted, evolved. When CO2 rose, plant life expanded. When oxygen spiked, animals grew. Earth wasn't a stage, it was a partner. Reacting, balancing, changing, but never tipping too far. That's not easy to replicate. Some see this as lucky timing. Others as built-in rhythm. Others still as intentional pacing, like a story that knows its own chapters. Whichever it is, the outcome is clear. The Earth has stayed alive, not just biologically, but geologically, chemically, atmospherically, for over 4.5 billion years. That's not just a coincidence. It's a context, one that allowed for seeds to grow, eyes to open, minds to wonder. So maybe when we speak of Earth's uniqueness, we shouldn't just think about where it is. We should also whisper thanks for when it is. Right here, right now, long enough for life to dream. We often think of the universe as cold, random, and indifferent. But look closely, beneath the chaos there are patterns. Soft ones, recurring ones, quiet rhythms that almost seem thoughtful. Look at a leaf. Look at the branching of a tree, the ripple of a shoreline, the spiral of a shell. These shapes aren't just beautiful. They're efficient. They serve a purpose. They repeat not because someone drew them, but because the rules of matter and energy seem to favor them. In rivers, in lightning, in your lungs. That's the whisper. Nature doesn't always shout intention, but it leans toward certain outcomes. The way water carves valleys, the way trees split light through leaves, the way blood vessels mirror roots, and neurons resemble galaxies. These aren't coincidences. They're convergences. Different systems following similar rules, arriving at familiar forms. And those forms? They're what keep life flowing. It's not just biology either. Mathematics seems to live in nature's bones. The Fibonacci sequence in sunflowers and pine cones. The golden ratio in shells and hurricanes. Fractals in ferns and snowflakes. Symmetry in faces, snow, crystals. None of these are required. But they appear anyway, over and over, in silence, as if something beneath the surface prefers balance, elegance, function. And when we, as humans, design something, buildings, logos, art, we often default to these same patterns. Not because we're copying nature, but because nature already lives inside our sense of beauty. Now let's go smaller. Inside a single cell, proteins fold with precise geometry. DNA spirals into a double helix, not because it's pretty, but because it works. Molecules lock together like keys and locks, matching shape and charge with almost eerie accuracy. Even randomness has boundaries. Even chaos dances in time. None of this proves that Earth was designed. But it makes design easier to imagine. Because when the same patterns emerge in galaxies, cells, and thought, you start to wonder, are we seeing coincidence? Or are we seeing the signature of structure? Maybe the universe doesn't speak in words. Maybe it speaks in shape, in ratios, in loops and spirals and symmetry that our brains recognize, not because they're human-made, but because they're truths too deep to ignore. Maybe, just maybe, these patterns aren't speaking to us. They're speaking through us. Let's go deeper, much deeper. Beyond the surface, beyond the shape of leaves and tides. down into the heart of the cell. There, nestled inside nearly every living thing, is a molecule that writes, reads, edits, and remembers. Its name is simple. Its function is profound. DNA. You've heard of it, of course. Deoxyribonucleic acid. A twisting ladder, a spiral staircase, a code. But what it does is stranger than fiction. DNA stores instructions. Billions of them. Written in a language with only 4 letters. A, T, C, and G. Always pairs with T. C always pairs with G. Those pairs form rungs on the ladder. But together they build something astonishing. DNA tells cells how to build proteins, those tiny machines that run your body. It decides your eye color, your height, your blood type. But it also runs deeper. Tells enzymes when to act. It governs repair systems. Tracks time, responds to damage, and changes, sometimes across generations. Some scientists compare it to software. Some to language. Some even to music, with rhythms and pauses, layers and repetition. But here's the strange part. DNA doesn't just store data. It interprets it. There are regulatory regions that act like punctuation. Genes that turn other genes on or off. Sequences that silence or amplify depending on signals from the body or environment. It's not static. It responds. And it doesn't even need to be active all the time. The same DNA in your skin cell is in your brain cell, your liver cell, your bones. But each cell reads only the part it needs. As if the body knows when to speak and when to stay silent. And yet, with all this complexity, the system is shockingly stable. DNA can copy itself, repair itself, and survive damage. It even folds itself inside a tiny nucleus using specialized proteins like histones. If stretched out, the DNA in one human cell would be about 2 meters long. And yet, it fits inside something smaller than a dust speck with order and access intact. That's not chaos. That's orchestration. Evolution tells us this came about through natural selection. Random variation filtered through survival. Mistakes that worked stuck around. And that's plausible, powerful, supported by evidence. But even within that frame, something about DNA feels different. Because randomness doesn't often lead to grammar, to structure, to something that behaves like a living script. Not just data, but meaning. Whether you believe DNA was created, discovered, or somewhere in between, it holds a truth too beautiful to ignore. Life didn't just emerge. It writes itself. And somehow it remembers the story. Let's stay inside the cell a little longer. Because if DNA is the script, then proteins are the actors, the builders, the messengers, the engines, and the guardians. And the cell? It's the stage. No, more than that. It's the world. A self-sustaining city enclosed in a membrane, humming with coordination. Proteins are built from amino acids, arranged according to DNA's instructions. But here's where it gets surreal. Once assembled, each protein folds itself into an exact 3-dimensional shape. And that shape determines what it does. Change a fold and you change a function. Sometimes just one wrong fold causes entire systems to fail. And yet, in healthy cells, this process happens millions of times per second. Effortlessly, reliably, as if molecules have memory, as if matter knows what it's meant to become. Some proteins are enzymes, catalysts that speed up chemical reactions. Reactions that, without them, would take years or centuries to happen. If at all. With enzymes, they happen in milliseconds. Other proteins form motors. Tiny machines that walk along cellular highways, carrying nutrients and materials. Some spin, some pump, some open and close like gates, regulating flow, maintaining pressure, controlling access. Even more astonishing, these systems aren't isolated. They talk to each other. A signal molecule bumps into a receptor. The receptor sends a message down a protein chain. The message reaches the nucleus. A gene activates. Protein is built. A response is triggered. All of this happens without consciousness. No thinking.
No commands.
Just structure, chemistry, and interaction so precise it borders on uncanny. It's like discovering a machine inside a droplet. Not clunky or industrial, but elegant, organic, alive. Every component has a role. Every pathway has feedback. Every response is proportional. Not too much, not too little. And when things go wrong, cells don't always collapse. They repair, they reroute, they adapt. Because even biology knows, resilience isn't about avoiding failure. It's about recovering from it. Again, none of this requires magic. Evolution explains a lot. The systems that work are the ones that survive. Over time, that filters for function. But still, the result is startling. Because when we build something with even a fraction of this complexity, we call it design. We patent it. We marvel at it. So when we find it already alive, already operating, under a microscope, we can't help but wonder, is this design? Or is this what design is trying to copy? Maybe the cell doesn't just sustain life. Maybe it teaches us what life truly means. We often think of life as spontaneous, messy, unpredictable, bursting with surprise. And it is. But underneath that spontaneity lies a secret. Life runs on clocks. Not digital ones. Not mechanical. But molecular. Rhythmic. Ticking in the dark. Unseen. Unforgotten. Inside nearly every organism, plant, animal, microbe, there are internal timekeepers. They're called circadian rhythms, and they're not just suggestions. They're deeply wired cycles of activity and rest, growth and repair. You have them. So do trees. So do coral reefs, mice, birds, and even bacteria. These clocks govern when we wake and sleep, when we digest, when our temperature rises, when hormones surge, even when cells divide. They don't rely on watches or calendars. They follow something more ancient, like rotation, orbit. Each day, Earth spins once on its axis. That spin creates day and night, the most fundamental rhythm we know. Over thousands of generations, life has linked its functions to this rhythm. Syncing biology to planetary motion. Your brain, for example, produces melatonin in the dark to help you sleep. Your body temperature drops slightly at night. Some genes only activate during certain times of the day. Even your immune system is stronger during waking hours and more vulnerable at night. That's not habit. That's biology listening to the Earth. But it doesn't stop at 24 hours. Earth's orbit around the Sun, 365.25 days, creates seasons. Temperature, rainfall, sunlight, all shift gently over time, and life responds. Bears hibernate, birds migrate, trees shed leaves or bloom, flowers open at dawn, insects emerge in spring, and then the cycle begins again. It's not static. It's a moving choreography with time as the conductor. Even smaller cycles exist. Inside cells, proteins rise and fall in predictable waves. These molecular loops don't just respond to change. They anticipate it. A cell knows when to prepare for DNA replication, when to repair damage, when to divide. Time in biology isn't just passing. It's embedded. The body doesn't react blindly. It remembers. It expects. So what does that mean? It means that you, as you sit or lie here, are part of a rhythm that predates language. Your heartbeat echoes the rotation of a planet. Your breath aligns with sunlight. Your thoughts move in waves set in motion by ancient spins. We are not separate from time. We are shaped by it. And all of this raises a quiet question. If life depends so completely on rhythm, who or what set the tempo? Maybe no one. Maybe rhythm just emerges, like ripples on a pond. But maybe, just maybe, this clockwork we call life ticks not because it must, but because it's meant to. Let's shift our attention from the invisible rhythms inside your body to the solid ground beneath your feet. Feels stable,
Permanent.
silent, but it isn't. The Earth's crust, the part we live on, isn't a shell. It's a puzzle of plates, cracked and moving, floating on molten rock. And without that quiet motion, life as we know it may never have happened. This is plate tectonics. Massive slabs of rock, some as large as continents, drift slowly across the surface of the Earth. They crash, grind, slip past each other, dive into the mantle, rise up again. And while this motion creates earthquakes and volcanoes, it also creates opportunity. It forms mountains which redirect weather and store snowpack, islands which become isolated laboratories of evolution, ocean basins where life began, continents that drift and collide, mixing species and climates. Without plate movement, Earth would likely be flat, eroded, and static. There would be no nutrient recycling, no climate regulation, no long-term habitability. Why? Because plate tectonics also connects deeply to Earth's carbon cycle. Here's how. Volcanoes release CO2 into the atmosphere. Rain absorbs CO2 and forms weak acids. These acids weather rocks, pulling carbon out of the sky. Rivers carry carbon into the oceans. That carbon gets buried in sediments. And then, subduction drags it deep into the mantle. Eventually, volcanic eruptions release it back. A cycle, a breathing planet, balancing greenhouse gases, not too hot, not too cold, across millions of years. Without it, climate would spiral. Oceans would turn acidic. Life would stall. But for this to work, Earth had to hit a narrow window. A crust thick enough to support continents. A mantle hot and fluid enough to allow motion. A planetary size big enough to retain heat. And a composition just right for internal convection. Too small? No plate movement, like Mars, frozen and geologically dead. Too active? Endless eruptions like Io, a volcanic chaos. Too quiet? Stagnation. No mountains, no oceans, no cycle. But Earth landed in the middle, stable yet alive. This slow, grinding machinery beneath our feet doesn't get much attention. But it shapes everything: weather, soil, habitats, extinctions, survival. Even the continents you stand on now, Asia, Africa, the Americas, are temporary arrangements, drifting over eons like slow-moving thoughts on the skin of a living world. So next time you stand barefoot in the grass, or hike a trail, or hold a stone in your hand, pause. What you're touching isn't just land. It's part of a system, old, dynamic, deliberate in rhythm if not in will. And that raises a thought. What kind of world builds itself from movement? A world that's not fixed, but alive. We often treat soil as something ordinary, dirty, background. But beneath our feet is one of the most complex and delicate systems on Earth. And it holds the key to nearly everything that breathes. Because soil isn't just dirt. It's memory. It's chemistry. It's life woven into matter. Let's look closer. Soil is made from ground-up rock, decayed plants, fungi, bacteria, air, and water. A chaotic mix that somehow becomes the bedrock of forests, farms, and entire ecosystems. Its texture matters. Too sandy? Water rushes through. Plants dry out. Too clay-heavy? Water pools. Roots suffocate. But just the right balance of minerals, organic matter, porosity, and something astonishing happens: growth. But soil isn't just a stage for plants to grow. It's a network, a conversation. Fungi thread through it like fiber optic cables, connecting trees in vast underground webs. Plants leak sugars through their roots to feed microbes. Microbes return the favor by fixing nitrogen, breaking down toxins, or warding off pathogens. And seeds? They don't just fall into soil. They fall into partnership. Each seed contains instructions, energy, the potential for life. But it waits. It listens for signals, moisture, temperature, light. And only when the time is right does it wake. Roots push downward, seeking minerals. Shoots reach upward, chasing sun. And in the process, a dance begins. That dance between seed and soil, plant and fungus, root and worm, isn't accidental. It's ancient, evolved, interdependent. This is symbiosis, not just coexistence, co-creation. Flowers evolved alongside bees. Trees communicate via underground networks. Some seeds won't even sprout unless burned, waiting for fire to reset the forest. Others travel on the wind, on fur, on water, designed not just to grow, but to spread. Nature doesn't just work. It works together. And when you look at how exact the fit is between plant and pollinator, root and soil, enzyme and nutrient, it starts to feel less like adaptation and more like assembly, not artificial, not mechanical, but precisely relational, as if life didn't just emerge from the earth, but grew with it, through it, shaped by every other life form that came before. Soil is not the end of something. It's the beginning of forests, of food, of civilizations, and in its dark, quiet layers, life writes its future. It's easy to forget how strange water really is. We drink it, we bathe in it, we see it fall from the sky and evaporate from streets. It runs through our pipes, our rivers, our veins. It is everywhere. And yet, of all the substances on Earth, water might be the most peculiar. Because the more you learn about it, the more it feels like an accident that shouldn't have worked, but somehow works perfectly. Let's start simple. Water is a molecule, 2 hydrogen atoms and 1 oxygen. That's it. But that arrangement creates a world of impossible behaviors. Unlike most substances, water expands when it freezes. That's why ice floats. Sounds minor? It isn't. If ice sank, lakes would freeze solid from the bottom up. Every winter would wipe out aquatic life. Spring would return to stillness, not survival. But ice floats, forming a lid that insulates life below. A quiet shield, a seasonal promise. Water also has a high specific heat, which means it takes a lot of energy to change its temperature. And that's a very good thing, because oceans absorb heat during the day and release it at night. They store summer and buffer winter. They keep the climate from swinging wildly between extremes. This thermal stability is what makes life possible not just near the equator, but across continents, seasons, generations. And then there's water's role as a solvent, perhaps the most important of all. It's called the universal solvent because it dissolves more substances than any other liquid. Why does that matter? Because life is chemistry. Inside your body, water carries nutrients, hormones, oxygen. It moves waste, regulates temperature, allows reactions to happen with precision and speed. Proteins fold in water. Enzymes operate in water. Cells swim in it. Birth begins in it. Water doesn't just support life. It enables it. But here's the twist. All of this floating ice, high heat capacity, dissolving power, comes from one detail, the angle between the hydrogen atoms. Change that angle just slightly and water behaves differently. It might freeze downward, boil too easily, refuse to mix, fail to carry heat. And if water fails, life doesn't just struggle. It doesn't begin. Now zoom out. Earth is drenched in water. Oceans cover 70% of its surface. Clouds move water through the sky. Rivers shape continents. Glaciers carve valleys. Rain feeds forests. And deep underground, aquifers store ancient reserves. Other planets may have water, Mars, Europa, and Enceladus, but Earth has liquid water in stable, massive quantities on its surface for billions of years. That's not typical. That's a gift. And it leads us to ask, why is Earth the only known world where water flows so freely, moves so softly, and fits so precisely into the needs of life? Maybe it's coincidence. Maybe chemistry just got lucky. Or maybe, somewhere in the rules of this universe, water was always meant to be this way. Not because it's special, but because it's what life needed most. Let's linger a little longer with water. Not as a fluid, but as a force that breathes across the face of the planet. Because Earth's oceans don't just sit still. They move, inhale, exhale, and in their rhythms, life finds balance. We've already said it, ice floats. But think about what that really means. When winter grips a lake or sea, ice begins to form from the top down. It thickens at the surface, not the bottom. That floating ice insulates the water below, like a blanket. And under that frozen shell, fish swim. Microbes stir. Life continues. If water behaved like most liquids, getting denser as it freezes, ice would sink. Layer by layer, entire bodies of water would freeze solid. And in spring, they'd take months to thaw. Life in those waters would have no chance. But that's not what happens. Water reaches its maximum density at around 4 degrees Celsius, just above freezing, which means the coldest water stays on top, forming ice that floats, while liquid warmth lingers below. A tiny physical quirk that makes survival possible. Now, shift your gaze from lakes to oceans. Earth's oceans are massive, covering 70% of the surface. They hold about 97% of all water on the planet. But they're not static. They move in great loops and gyres, circulating heat, nutrients, gases. Warm water travels from the equator toward the poles. Cold water sinks and returns toward the tropics. This system, called thermohaline circulation, is sometimes nicknamed Earth's global conveyor belt. Regulates climate, distributes oxygen, transports nutrients, connects ecosystems thousands of kilometers apart. Without it, tropical regions would overheat, polar zones would freeze harder, and much of marine life would vanish. Even the breath of the ocean is essential. Oceans absorb carbon dioxide from the atmosphere. They also release it, a natural exchange that helps regulate Earth's climate. Phytoplankton, the microscopic plants of the sea, consume CO2 through photosynthesis. Just like trees, they produce oxygen, feed the food chain, and form the base of marine ecosystems. The ocean doesn't just support life, it generates it, but this balance is fragile. Too much warming, ocean currents slow. Too much CO2, waters acidify. Too much melting ice, salinity shifts. Circulation weakens. That's why understanding water's role isn't just academic. It's existential, because this simple substance, which flows so freely through our lives, also holds climate, ecosystems, weather, and breath in its invisible hands. And it all hinges on a few degrees, a few molecular quirks, a few perfect imbalances. Ice floats, oceans breathe, rain falls, lakes don't freeze solid, rivers don't boil, clouds don't vanish. That's not just chemistry, that's continuity. And the more we understand it, the more it feels like a miracle in motion. Take a breath. Now another. Feels easy, doesn't it? But what you just did, pulling invisible gases into your lungs, absorbing oxygen, releasing carbon dioxide, only works because of something delicate, vast, and astonishing. Earth's atmosphere. We barely notice it. We move through it like fish through water. And yet, without it, life wouldn't just be difficult, it would be impossible. Earth's atmosphere is thin. Compared to the planet's size, it's like a coat of paint on a basketball. But it holds everything: breathable air, weather, climate, sound, protection. It extends roughly 100 kilometers above sea level. But 95% of its mass is within the first 15 kilometers. That tiny sliver is where we live, breathe, and survive.
Composition metteurs.
Roughly 78% nitrogen, 21% oxygen, and 1% argon, carbon dioxide, water vapor, and trace gases. But those numbers aren't arbitrary. If oxygen were much higher, fires would be uncontrollable. If lower, large animals couldn't survive. Without nitrogen, plants couldn't grow. Without carbon dioxide, photosynthesis would halt. Without water vapor, no clouds, no rain, no weather. This isn't just air. It's precision. And it didn't start this way. Earth's early atmosphere was hostile, thick with methane, ammonia, volcanic gases, toxic to animals, but perfect for early microbes. Then came a revolution. Photosynthetic organisms like cyanobacteria began releasing oxygen. Slowly, quietly, relentlessly. The great oxygenation event transformed everything. Oceans rusted. Some life died. Other life adapted. Eventually, the atmosphere reached the balance we know today, supporting fire, breath, and complexity. A crisis became a new beginning. But the atmosphere isn't just composition. Its behavior protects us. The ozone layer shields life from ultraviolet radiation. The magnetic field, generated by Earth's core, deflects solar wind. The atmosphere itself burns up meteors before they reach the ground. Pressure keeps water in a liquid state, enabling hydration and blood flow. It warms us, too. Certain gases, like CO2 and water vapor, trap heat in a gentle greenhouse effect. Without it, Earth would average around -18 degrees Celsius. Instead, it holds steady near 15 degrees Celsius, perfect for liquid water and living cells. But too much greenhouse gas, and that same warmth becomes danger. Balance is key, and Earth has maintained that balance for eons. Even through volcanic winters, ice ages, and warming periods. The atmosphere is also a transport system. It carries moisture from oceans to mountains, heat from equator to poles, seeds, spores, pollen, even microbes across continents. It shapes storms, winds, seasons, currents, migration routes, turns Earth into a world of movement, always cycling, always breathing. And yet, it remains almost invisible. A blanket, a barrier, a bridge between the ground and the stars. Not alive in itself, but very much part of the living system. So the next time you feel the breeze on your face, or hear thunder in the distance, or watch clouds gather, know this: you're not just watching weather. You're standing inside the lungs of a planet. Every night, when the sky is clear, we see it silent, pale, watchful. The moon feels familiar, gentle, almost decorative, but its presence is anything but passive. In truth, the moon is one of the most influential forces shaping life on Earth. Start with the tides. Twice each day, oceans rise and fall, drawn by the moon's gravity. These tides move nutrients through coastal waters, stir ecosystems in estuaries and reefs, shape shorelines, feeding marshes and wetlands, create wet-dry cycles, believed to have helped early life form in tidal pools. Without the moon, tides would still exist, driven by the sun, but they'd be far weaker, less rhythmic, and less transformative. But the moon does more than move water. It stabilizes Earth's tilt. Our planet leans at 23.5 degrees, which gives us seasons. Without the moon's pull, that tilt could drift wildly. It might swing between near upright and extreme angles. That would wreak havoc. Summers could scorch where winters once froze. Growing seasons would vanish or jump unpredictably. Climate patterns would become erratic and unstable. The moon keeps that tilt steady over long timescales. A cosmic hand on the spinning top of Earth. That quiet balance may be what allowed ecosystems and civilizations to flourish. The moon also slows Earth's rotation. Long ago, a day on Earth was just 6 hours. Over billions of years, the moon's tidal pull has stretched it to 24. This slower spin gives more time for temperatures to stabilize between day and night, gentler wind patterns, longer cycles for plants and animals to adapt. Still changing gradually. The moon is drifting away about 4 centimeters per year. One day, total solar eclipses will end. But for now, the alignment remains perfect. And then there's moonlight. Not just romantic, not symbolic, biological. Many animals use moonlight to migrate, hunt, hide, reproduce. Coral reefs spawn in sync with full moons. Birds use moonlight to navigate. Even some plants respond to its faint glow. To us, it may feel soft, distant, but to life, it is clockwork. A second rhythm layered over the sun. Now imagine if Earth had no moon. That's not hypothetical. Mercury and Venus have none. Mars has 2 tiny captured asteroids, too small to stabilize anything. Without a moon, Earth's climate would be more chaotic. Tides weaker, days shorter, life different. Possibly less stable, less diverse, less likely. Theories say the moon formed from a collision, a Mars-sized object smashing into early Earth. Debris flew into orbit. Over time, it coalesced. But the angle, speed, timing, and composition all had to align just right for that impact to yield a large, stable moon. Most impacts don't do that, but this one did. And the result is the balance we live inside every single day. So next time you look up at that quiet face, remember, the moon is not decoration. It is design in motion, whether by physics, fate, or something deeper. It is the reason the Earth doesn't wobble into chaos. And maybe the reason we're still here to look up and wonder. We've already seen how the moon shapes tides, anchors Earth's tilt, slows our spin, and guides the rhythms of life. But how the moon got here, that's where the mystery deepens. Because of all the rocky planets in the solar system, only Earth has a moon this large relative to its size. And that is strange. Most moons are tiny, captured fragments. Mars has two shaped like misshapen potatoes. Venus and Mercury have none. Jupiter and Saturn? Dozens of moons, yes, but their planets are massive. Earth is unique. Its moon is 1/4 the width of the planet. A massive presence in our sky. And yet, its origin story reads like a cosmic accident. The leading theory is called the giant impact hypothesis. About 4.5 billion years ago, a planet-sized object, roughly the size of Mars, slammed into the young Earth. We call this hypothetical planet Theia. The collision was cataclysmic. It vaporized rock, melted crust, spewed debris into orbit, and from that debris the moon was born. But here's where it gets eerie. For this to work, Theia had to hit at the right angle, not a direct hit, not a glancing blow. It had to be big enough to eject material, but not so big that Earth was destroyed. The resulting debris had to coalesce, rather than scatter. The moon had to settle into a stable orbit, close enough to influence Earth, but far enough to avoid being pulled back in. Any variation, too much energy, wrong timing, different materials, and the moon wouldn't exist. But it does. And not only does it exist in the exact place and size needed to produce strong, consistent tides, stabilization of Earth's tilt, a precise orbital rida, perfect solar eclipses, where the moon can fully block the sun despite being 400 times smaller, because it's also 400 times closer. That coincidence alone, eclipse symmetry, has no survival function. It doesn't benefit life, but it captivates our eyes. It draws us upward. It whispers. Meaning? Some scientists argue. We're reading too much into it. We're here because things worked, not the other way around. In a trillion other timelines, Earth has no moon. No stability, no us, but others pause. Because the moon doesn't just exist. It's exactly what Earth needed at every stage of its evolution. It stirred the oceans, balanced the planet, slowed the clock, anchored life, and then it became part of our myths, our poetry, our culture, our cycles. Is that just physics? Maybe. But here's the thing. Most planetary collisions don't result in a companion. They result in chaos. But this one, it gave us a mirror in the sky, a stabilizer, a clock, a beacon, a gift. It never flickers. It doesn't hum or glow. You've never seen it, but you've felt it every moment of your life. Gravity, the quiet architect of everything you know. Compared to the other fundamental forces of nature, electromagnetism, the strong and weak nuclear forces, gravity is absurdly weak. A tiny magnet can lift a paperclip against the pull of an entire planet. And yet, gravity wins. Every time. Because it never turns off. It never stops. And it acts on everything that has mass. From galaxies to raindrops. From you to the orbiting moon. It was gravity that pulled scattered dust into clumps. That turned clumps into planets. That lit the sun. That arranged the solar system like clockwork. And when Earth formed, gravity sorted it from the inside out. Heavier elements, iron, nickel, sank inward, forming the core. Lighter materials floated upward, creating crust and atmosphere. That sorting gave Earth a magnetic field, a molten mantle, and a surface thin enough for life to shape. Without that inner gravity-driven movement, no plate tectonics, no recycled carbon, no mountains or continents. But gravity doesn't just shape the inside. It choreographs the dance of everything outside, too. It keeps the moon in orbit, the Earth around the sun, the tides rising and falling, seasons steady, time measurable, your day, your year, your rhythm, all timed by gravity. And it's precise. Too much gravity? Earth collapses under its own weight. Atmosphere is crushed. Bodies adapt or break. Too little? Air escapes. Oceans boil away. Nothing holds together. But Earth got just enough. And still, gravity reaches farther. It holds the solar system together. It organizes galaxies. It bends light itself, a phenomenon called gravitational lensing, which helps us detect black holes and distant stars. That's how we know dark matter exists. Not because we see it, but because we feel what gravity feels. Here's what makes gravity so extraordinary. It doesn't need a surface to act. It doesn't require touch. Simply is constant, global, quietly shaping the rules of possibility. Mountains form where plates collide, driven by gravity. Rivers flow downward, sculpted by gravity. Rain falls, trees rise, blood circulates, all because of this unseen hand. Even your sense of up and down, your orientation in the world, is gravity whispering into your bones. And then there's the human side. Your muscles, your posture, your balance, all tuned to Earth's gravity. In space, astronauts experience muscle loss, fluid shifts, even changes in vision. Because the body you inhabit was designed, adapted for this exact pull. 9.8 meters per second squared. A number that means nothing in poetry, but everything in survival. So yes, gravity may be subtle, but it is never silent. It is the reason Earth holds together. The reason water flows. The reason the moon stays. The reason life can rise, walk, reach, and return. It's not flashy. It's not loud. It's just everywhere. And without it, nothing. There's something comforting about a circle. Something ancient.
Familiar.
Complete. No beginning. No end. Just rhythm, rotation, return. And when you start looking, you realize nature loves circles. The Earth spins in a circle. The moon orbits in one. The planets dance around the sun in elliptical rings. Galaxies swirl in spirals of stars. Seeds curl. Snail shells coil. Tornadoes twist. Water drains in a whirl. Vines spiral around sunlight. These aren't just beautiful shapes. They're functional. Circles and spirals appear when balance meets motion. When forces pull and push evenly. When growth must expand without breaking symmetry. Take the spiral. From sunflowers to hurricanes, it shows up where things grow outward and rotate, adding layers without chaos, spreading energy efficiently. Many of these spirals follow a specific mathematical pattern. The Fibonacci sequence. Start simple: 0, 1, 1, 2, 3, 5, 8, 13. Each number is the sum of the two before it. And yet, that humble formula shows up everywhere. In the arrangement of leaves, the curve of horns, the swirl of galaxies, even in human-made structures, intuitively, almost instinctively. Why? Because it's efficient, because it fits, because form follows function, and nature loves to repeat what works. Then there's symmetry. Split a butterfly, a leaf, a snowflake, and you'll find matching halves. Not perfectly, but reliably. Symmetry distributes stress evenly, supports balance in movement, enhances survival. Many animals evolved symmetrical traits for speed, agility, perception. But it's more than practical. We, as humans, are drawn to symmetry. We find it beautiful, harmonious, trustworthy. The more symmetrical a face, the more attractive we tend to find it. The more symmetrical a building, the more serene it feels. It's as if our minds are wired to recognize order and relax in its presence. Some call these shapes sacred geometry, not because they're magical, but because they feel meaningful. Hexagons in honeycombs, fractals in ferns, tiling patterns in turtle shells, the spiral of a fingerprint, the path of a planet. These shapes aren't invented. They're discovered over and over across scales, species, and systems. Even in the microscopic, we see it. Crystals form geometric lattices. Proteins fold into precise 3D shapes. DNA coils in a double helix. Neurons branch like lightning or tree roots. The deeper we look, the more we realize. The universe doesn't build at random. It builds with rules. Not rigid laws, but patterns, preferences, Forms that are repeated because they are stable, efficient, timeless. Maybe that's all it is, the physics of structure. Or maybe something more poetic, a universe that leans toward beauty, that chooses balance where possible, that prefers elegance when complexity arises. Not because it needs to, but because somehow it can. So the next time you trace a spiral in a seashell, or watch a ripple spread on water, or look at the full moon rising round and still, know this, you are not just seeing a shape. You are seeing an echo of motion, of meaning, of something written not in words, but in form. Zoom in on a fern, not just the leaf, but one tiny frond. Then zoom in again on an even smaller segment. What do you see? The same shape, over and over, smaller and smaller, patterns within patterns, echoing endlessly. That is a fractal. Fractals are structures that repeat themselves at different scales. They're not just mathematical curiosities. They are one of nature's most consistent designs. You'll find them in the branching of trees, the arteries of your body, river systems from space, lightning bolts slicing the sky, coral reefs, mountain ranges, snowflakes. Fractals are messy and exact at the same time. They can be complex without being chaotic. Because even in apparent randomness, the pattern persists. Why does nature use them? Because they are efficient. A tree needs to spread leaves into sunlight. A lung needs to maximize surface area to absorb oxygen. A blood vessel needs to reach every cell, but with minimal material. Fractals solve these problems with elegance. They allow large systems to grow without outgrowing their space. Let energy and information travel quickly. Balance complexity with simplicity. It's no exaggeration to say that you are made of fractals. Not just in form but in function. And it's not limited to the biological. Clouds, coastlines, cracks in drying mud. Even galaxies show fractal-like clustering, structures inside structures. The entire universe may be built with this logic. Small-scale mirrors of large-scale order. The microscopic reflecting the cosmic. Mathematically, fractals can be generated with simple formulas. But the outcomes are anything but simple. They are intricate, infinite, alive. Some scientists believe fractals offer the best language we have to describe living systems. Not straight lines, not perfect circles, but recursive irregularity where the edge never smooths out no matter how close you look. Sound familiar? Because that's what life is. Unfinished, uneven, yet undeniably patterned. And here's something worth pausing on. When humans design something, cities, machines, circuits, we often work in boxes, in grids. Clean, predictable, contained. But nature leans toward fractals. Not because they're pretty, but because they work. They adapt. They flex. They grow. So what does that mean? It means that the deeper we look, the more we see not just repetition, but resonance. Not just structure, but a kind of logic within chaos. Fractals suggest that life isn't built with blueprints, but with principles, rules that whisper rather than shout. So next time you look at the veins of a leaf, or the cracks in dry earth, or the shape of lightning frozen in a photo, don't just admire the pattern. Ask yourself, is this just what matter does? Or is this what life needs? Because maybe, just maybe, they're the same thing. There's a number that keeps appearing in art, architecture, nature, and even your body. It's not famous like pi or e, but it hides in plain sight. That number is 1.618, and it's called the golden ratio. Mathematically, it's defined this way. A line is divided into two parts, such that the whole divided by the longer part is equal to the longer part divided by the shorter part. It sounds abstract, but this ratio, often written as the Greek letter phi, shows up everywhere, and not just by chance. In nature, you'll find the golden ratio in the spiral of a nautilus shell, the pattern of sunflower seeds, the curve of hurricanes, the arrangement of pine cones and pineapples, the growth of leaves around a stem known as phyllotaxis. Each new leaf grows at an angle that maximizes exposure to sunlight, and that angle, roughly 137.5 degrees. A golden angle, derived from phi, not perfect, not engineered, but consistent, emergent. In animals, phi appears in the proportions of body parts. The distance from shoulder to fingertips, from navel to floor, from facial features to the skull. These alignments aren't exact rulers, but they echo the same proportions again and again. Even in humans, our perception of beauty often aligns with this ratio. We prefer faces with certain distances between the eyes, mouth, and chin, whether we know it or not. It's as if evolution favors symmetry and proportion not just for survival, but for connection. But it doesn't stop at biology. Ancient structures reflect phi, long before it was named, the Parthenon in Greece, the Great Pyramid of Giza, the Mona Lisa,
Da Vinci's Vitruvienmann.
Modern-day credit cards, books, screens, even logos. Designers, knowingly or intuitively, keep using the golden ratio because it feels right. Not too tall, not too wide, not too simple, not too complex, just balanced. And this raises an uncanny thought. Why does one ratio appear across plants, animals, architecture, art, and emotion? Is it coincidence? Or is it a kind of universal aesthetic? A shape the universe keeps drawing, not because it's beautiful, but because it's efficient, stable, and resonant. Maybe what we call beauty is just our brain recognizing patterns that nature already trusts. The golden ratio, fractals, spirals, symmetry, they don't prove anything mystical, but they suggest something meaningful, that form follows function, and that beauty may follow biology, that the things we find pleasing may not be learned, but inherited, woven into the way life moves, breathes, grows. So next time you're struck by a pattern,
O shell, o flower, o storm.
don't just admire its shape. Ask, why does it feel so familiar, so peaceful, so right? Maybe it's not just math. Maybe it's the language of life itself. Imagine building a planet from scratch. You're handed a set of dials: temperature, pressure, gravity, atmosphere, rotation, distance from the sun. And your goal? Make a world that can support life. Not just microbes, but forests, fish, thought. Where would you even begin? Because the margin for error is vanishingly small. Start with temperature. Too hot, and water evaporates. Proteins break down. DNA unravels. Too cold, and chemical reactions grind to a halt. Water freezes. Life can't move. Earth sits in what's called the habitable zone, not too close, not too far from the sun. Just right for liquid water. But that alone isn't enough. You also need the right atmosphere to trap heat gently but not too much. The right planetary mass to hold on to gases but not collapse under its own gravity. The right magnetic field to shield life from solar and cosmic radiation. The right rotation speed to avoid wild temperature swings between day and night. The right axial tilt to create seasons but not extremes. The right surface composition with both land and sea, mineral diversity, and fertile soil. The right chemical ingredients: carbon, hydrogen, nitrogen, oxygen, phosphorus, sulfur. And here's the wonder: Earth got all of them. Not perfectly, not permanently, but just enough. Let's break that down. The atmosphere, thick enough to protect, thin enough to breathe. Oxygen for animals, carbon dioxide for plants, water vapor for weather, ozone to filter UV rays. The gravity, strong enough to hold an atmosphere, gentle enough that birds can fly, perfect for bones, blood flow, cellular structure. The day length, about 24 hours, fast enough to prevent heat overload, slow enough for photosynthesis, rest, and circadian rhythm. The seasons, predictable, moderate, not ice ages every year, not eternal summer. Even the sun, a G-type main sequence star, is unusually stable.
No violent flares. No dramatic dimming.
A reliable provider of light and heat. So how rare is that? Well, the more exoplanets we discover, the more we realize how easy it is to get one thing wrong. Some worlds rotate too slowly, one side scorches, the other freezes, lack magnetic fields bathed in radiation, are too massive gas giants with no solid surface, are too small, unable to hold an atmosphere, orbit unstable stars, flares, collapses, chaos. In a cosmic sense, Earth isn't just another planet. It's a tuned instrument. Does that prove design? Not necessarily. But it does ask a quieter question. How many dials had to land in the right place before life could even take its first breath? And once that breath began, how did it keep going? Because even today, all those dials still matter. And Earth somehow keeps the balance. Not frozen, not burning, not stagnant, not spiraling, just alive. So far, we've explored Earth's remarkable qualities. Its rhythms, balance, symmetry, and stability. But what if it's not just Earth that's just right? What if the entire universe is? That's the heart of the idea known as the fine-tuning paradox. Here's the puzzle. The laws of physics, those deep, invisible rules, depend on certain constants. Values like the strength of gravity, the charge of an electron, the mass of a proton, the expansion rate of the universe, the cosmological constant which governs dark energy. And if you change any one of them by even the tiniest amount, the universe as we know it doesn't work. Stars don't form, atoms don't hold, planets don't exist, chemistry can't happen, life has no chance. For example, if gravity were just a little stronger, stars would burn out too fast, collapsing into black holes. A little weaker and no stars would ignite at all. If the strong nuclear force which holds atomic nuclei together were slightly weaker, no carbon would form in stars. And without carbon, no DNA, no proteins, no us. If the expansion rate of the universe were a fraction faster, matter would fly apart before galaxies could form. A fraction slower, and the universe would collapse before anything cooled. These aren't small tweaks. These are knife's-edge balances. And that raises a breathtaking question. Why are the numbers what they are? There are a few possible answers. It's just luck. We won the cosmic lottery. Trillions of universes may exist, and we happen to live in the one that works. It's inevitable. Maybe we misunderstand. Maybe deeper laws require these constants to be what they are. It's designed. Maybe the universe was set up for life by something, someone, or some process beyond our comprehension. It's anthropic. Of course we find the universe fine-tuned, because if it weren't, we wouldn't be here to notice. Each answer opens new doors. None of them close the mystery. The fine-tuning paradox doesn't demand belief. It demands awe, because even if life isn't the purpose of the universe, life only exists because the universe allows it. And not grudgingly, but gracefully, like a key that fits a lock, like a melody that lands on the right note, like a stage that's been waiting for something to walk onto it. Some call it a coincidence. Others see intention. But whatever you believe, here's the truth. The universe didn't have to be this way. And yet, here it is. Let's start with something small. A speck of dust. A bit of stardust. A single carbon atom. It floats in the cold silence of space. Alone, insignificant. But given the right conditions, that tiny carbon can become life. Carbon is the backbone of biology. It forms long chains, rings, lattices, more than any other element. It bonds with hydrogen, oxygen, nitrogen, phosphorus, sulfur, the building blocks of amino acids, proteins, DNA. Its versatility is what allows complex chemistry to happen. What gives cells their structure. What lets molecules carry instructions. Without carbon, there are no organisms.
No lungs. No brains.
No leaves or lungs or laughter. And where did it come from? Stars. Carbon didn't exist in the early universe. It was forged in the cores of aging stars via stellar nucleosynthesis. When those stars exploded as supernovae, they scattered carbon across the cosmos. That carbon landed here, on a cooling planet, in warm ponds, deep oceans, volcanic vents. And over time it linked, built, copied, adapted, until one day carbon began to notice itself. That's what consciousness is, the universe somehow waking up. Think about that. The atoms in your brain were once inside stars. They drifted for billions of years, then gathered into molecules, cells, organs, thoughts. Now they're asking questions about themselves, about origin, about meaning. We often imagine that consciousness is separate from nature, something special, something other. But what if it's not? What if thought isn't opposed to matter, but a natural extension of it? What if carbon wasn't just capable of life, but destined for it? Not through purpose, but through possibility. From atoms to molecules, from molecules to membranes, from cells to neural networks, from networks to awareness. That's not magic. That's structure, layered over time. But here's the question that lingers. Why does matter care? Why does a system of neurons suddenly begin to feel, dream, imagine? Why does the universe not only function, but also wonder? We can explain the how, electrical signals, neurotransmitters, evolutionary advantage. But the why remains elusive. Why does consciousness feel like more than function? Why does thought carry weight? Emotion carry depth? Awareness carry beauty? These questions don't have easy answers. But maybe that's the point. Maybe consciousness is the part of the universe that knows it's alive, that longs to understand, that whispers, what else might there be? And all of that, from stars to synapses, began with carbon, a silent, stable, elegant atom that became the bridge between dust and awareness. Consciousness is one thing, but intelligence, the ability to plan, problem solve, remember, and imagine futures that haven't happened, that's something else entirely. And it raises a fascinating, unsettling question. Was intelligence meant to happen? Or did it just accidentally emerge? From a biological perspective, intelligence is often explained as a tool, a survival advantage. The smarter an organism, the better it adapts. Finds food,
Avoid danger.
builds shelter, navigates change. But think about this. For 3.5 billion years, life on Earth existed without brains. Bacteria, algae, corals, even insects, they thrive with little or no intelligence. And yet, somehow, on one particular branch of evolution, a thinking mind appeared. Not just instinct, not just reaction, but reflection. And with that came questions. Who am I? Where did I come from? What happens after death? Why does the universe exist? No other species seems to ask those questions. They live, they survive, they feel, but they don't seem to wonder. We do. So what changed? Some theories suggest it was tool use requiring planning and imagination, fire which changed diet, social structure, and time use, language which allowed memory to extend beyond one brain, social cooperation which rewards emotional awareness. These are valid, but there's still mystery, because intelligence didn't just appear. It flourished. We didn't just solve problems. We built art. We wrote poems. We launched satellites. We dreamed of things we've never seen. Which brings us back to the question, was this the goal of evolution all along? Or was it a byproduct, an unintended result of complexity gone too far? Some biologists say, yes, it's just a fluke, like a side effect, like heat from a light bulb, it comes with the function, but it isn't the point. Others argue, no, intelligence is inevitable. The more complex life becomes, the more likely it is to need feedback, memory, planning. Eventually, that turns into something like us, and still others suggest something deeper, that maybe the universe is structured in a way that invites awareness, that favors self-reference, that leans toward minds not because they're useful, but because they're the only way the universe can see itself. That's where philosophy steps in. If a tree falls and no one hears it, if a galaxy spins in silence, if time flows with no witness, does it matter? Or does consciousness, however rare, give context to existence? Maybe intelligence isn't the point of the universe, but maybe it's the part that turns being into meaning. You are stardust. Yes. But you're also story. And stories don't just exist. They search. They reach. They evolve. Just like you. We like to imagine evolution as a straight line. A climb. A ladder. From single-celled life to humans, with each step more advanced, more inevitable. But that's not how nature works. Evolution isn't a staircase. It's a branching tree, full of wrong turns, dead ends, and strange, beautiful accidents. And many of those accidents, the very ones that almost stopped life, are the reasons we exist at all. Let's start 66 million years ago. An asteroid slams into Earth, near what is now the Yucatan Peninsula. The impact is devastating. Fires rage. The sky darkens.
Plenty.
Over 75% of all species vanish, including the dinosaurs. It was a mass extinction, a planetary tragedy. But it also left ecological space, for mammals to thrive. Tiny, furred creatures that once hid in the shadows now ventured into the open. And from their lineage one day came you. Or go back even further. Roughly 2.5 billion years ago, tiny cyanobacteria began releasing oxygen as a waste product. Harmless, right? No. Oxygen was toxic to most early life. It caused a global catastrophe, the Great Oxidation Event, that nearly wiped the slate clean. But some organisms adapted, used oxygen, harnessed it to create energy with astonishing efficiency. And eventually, that oxygen-filled atmosphere made complex life possible. What started as a mistake became the air you breathe. Or consider the strange event known as endosymbiosis. One ancient cell swallowed another, a smaller cell that once lived on its own. Instead of digesting it, they began living together. The small one became a mitochondrion, the powerhouse of eukaryotic cells. That moment, an accident of cooperation, led to plants, animals, fungi, and us. A merger, not a conquest. Even our genomes are filled with history's glitches. Copied genes, junk DNA, fragments from viruses. Some parts are broken, others are borrowed. Some we still don't understand. But in that mess, evolution finds new tools. It builds from improvisation, not blueprints. And somehow, what's born is coherent, functional, even elegant. So what does all this mean? That life isn't a clean process. It's a dance of chaos and correction. It grows not despite error, but because of it. Accidents destroy, yes, but they also create space for adaptation, for innovation, for something unexpected to emerge. If evolution had been flawless, we might not exist at all. It was the detours, the dead ends, the collapses and collisions that shaped the world we now call home. So maybe, you sitting here listening, wondering, you're not the result of perfection. You're the result of possibility, of failure redeemed, of randomness repurposed, of a story that almost didn't happen, but did. Imagine life as a river trying to flow across the universe. Not calmly, not continuously, but in bursts, surges, rare chances. Because while life may be common, complex life, like animals, consciousness, civilizations, may be incredibly rare. Why? Because of something called the Great Filter. The idea is simple and chilling. Along the timeline from lifeless planet to advanced civilization, there are choke points. Moments where life could stall, fail, never go forward. And Earth? Somehow it passed through them all. Filter 1. Life emerging from chemistry. We don't fully understand how it happened. Organic molecules became self-replicating. Maybe it was inevitable. Maybe it was a fluke. But it happened. Filter 2. Single-celled life becoming multicellular. For billions of years, life stayed small, simple. Then cells began to specialize, communicate, cooperate. From that leap came everything from jellyfish to giraffes. Filter 3. Sexual reproduction. Mixing genes allowed for faster evolution, greater diversity, but also greater complexity. More things that could go wrong. Filter 4. Intelligence. Brains are expensive. They need fuel, time, protection. But once they appear, they reshape the world. Filter 5. Tool use. language, culture, technology, not just surviving but building, encoding knowledge across generations. Filter 6. Avoiding self-destruction. Fire.
Va.
Environmental collapse. Nuclear weapons. Ai. Technology brings power, but also risk. Filter 7. Spreading beyond Earth. Because eventually the sun will change. Earth will change. And if life wants to continue, it must look upward, outward. Now ask yourself, how many of these filters has Earth passed? All of them so far. And what if most planets never make it past filter 1? What if they get stuck at 2 or 3? What if intelligence always leads to extinction? That would make us rare, precious, almost impossibly lucky. Or maybe we haven't reached the hardest filter yet. Maybe the real test is still ahead. To survive ourselves, to balance curiosity with caution, to grow wiser, not just smarter. Because intelligence is a tool, but wisdom is what we do with it. This idea doesn't answer anything, but it reframes everything. We may not be alone in the universe, but we may be first, or among the first to glimpse a truth, that existence is not just given. It's earned through resilience, reflection, and restraint. So when we wonder, why are we here? Or where is everyone else? The answer might be, you are the survivor, the one that made it through. And now, it's your move. On clear nights, when you look up into the black canvas of space, you're seeing a truth that's both breathtaking and unnerving. There are hundreds of billions of stars, many with planets, many in the habitable zone. And yet, the sky remains silent. This is the core of the Fermi paradox. If the universe is full of stars, time, and possibility, where is everyone? It's not just a science fiction question. It's a real one. Given how old the universe is, 13.8 billion years, and how quickly civilizations could, in theory, spread across galaxies, we should, statistically, see something by now. Signals, lights, machines, probes, any trace of someone somewhere doing anything. But what we get is nothing. No confirmed contact.
No alien ruins.
Just static, distance, quiet. So again, why? There are many theories, none proven, all humbling. We are early. Life is still rare. The universe is vast. Maybe intelligent species just haven't had time to reach us yet. We are alone. Earth is a freak event. Life is nearly impossible elsewhere. They are hiding. Advanced civilizations choose not to reveal themselves. We're in a kind of cosmic nature reserve, observed but untouched. They are gone. Civilizations rise and destroy themselves through war, AI, environmental collapse. Intelligence might always be temporary. We're not listening right. Maybe alien life doesn't use radio waves or speaks in ways we can't detect. Maybe we're ants trying to understand symphonies. The zoo hypothesis. We're being left alone on purpose. A kind of interstellar experiment. Watched but never contacted. Each idea is sobering. Each one points to how much we don't know. But maybe the silence isn't a warning. Maybe it's an invitation to appreciate what we have, to cherish this fragile moment of awareness, to remember, just because we don't hear others, doesn't mean we aren't rare. And there's beauty in that silence, because it gives us time to grow before we meet the unknown, to wonder, to search, to become something worthy of the next voice we hear. Maybe the quiet sky isn't empty. Maybe it's waiting. Maybe Earth is the first note in a universal symphony yet to begin. Until then, we listen to the stars, to ourselves, to the silence, and maybe one day to someone else listening back. Close your eyes and imagine a world. No people, no animals, no eyes, no thought. And yet, the mountains still rise. The clouds still drift. The snowflakes still fall in perfect hexagons. Would that beauty matter? Without a witness, all around us, Earth creates patterns, rhythms, and elegance that no one taught it to make. Ice crystals form fractals as they freeze. Auroras shimmer across polar skies, dancing with solar wind. Desert dunes ripple in wind-driven waves. Bioluminescent algae light up oceans like stars underwater. Opals refract color with microscopic precision. Rainbows arc across sky and spray, mathematical and miraculous. None of it is done for us. None of it needs an audience. And yet, it exists. Before humans, flowers bloomed in vibrant color. Before eyes, the ocean swirled in sapphire hues. Before sound, thunder cracked and echoed through valleys. Beauty didn't begin when we arrived. It's older, deeper. It may not even need meaning. It may simply be. Still, we can't help but ask, what is beauty for? Is it evolutionary?
Do bright theaters attract mates?
Do symmetrical faces suggest health? Sure, that explains part of it. But what about the things that have no function? The sound of wind through trees, the glow of a sunset over the ocean, the silence of snow falling at night, the Milky Way stretched across a mountain sky. Why do they move us? Why do they make us feel small but also connected? Maybe beauty isn't about use. Maybe it's about recognition, a moment where form and feeling align, where you see something and your brain, your body, your soul all say, yes, this is right, even if you can't explain why. And here's a thought that lingers. What if the universe would be beautiful even without us? But somehow we're the part that gets to notice? What if awareness doesn't create beauty, but completes it? Like the eye completes the rainbow, like the ear completes the song, like you right now, listening, breathing, wondering, complete the night. So when you gaze at the sky, when you touch a leaf, when you catch a glimpse of something that stirs your heart, know this, that feeling is real. That moment is real. And in it, you're not separate from beauty. You are beauty, alive, aware, witness. You wake up, you open your eyes, and the world fits you. Your lungs match the air. Your eyes match the light. Your hands fit the tools you build. Your body holds warmth, feels gravity, craves water, knows rest. So it's tempting, very tempting, to wonder, was this world made for you? The ancient thinkers believed so. Many early cultures saw Earth as the center of the universe. A stage built for humans. A garden. A gift. A home with us at the heart of it. And in many ways, that's how it feels. Because everything we need is here. The air doesn't poison us. The sun doesn't burn us. The water flows, the food grows, the seasons turn. It's as if someone took a list of biological requirements and checked every box. But science tells a different story. It says no, Earth wasn't shaped for us. We were shaped by Earth. We didn't land here ready-made. We adapted over eons. To this light, this air, this tilt, this pressure, this day-night cycle. Eyes evolved because there was light. Lungs because there was oxygen. Limbs because there was land to walk on. We weren't placed into the world. We rose with it, like a sculpture shaped by its chisel, like a melody that fits the key. So which is true? Is this planet custom-made for us? Or are we the product of its quiet, relentless molding? Maybe both. Because in either case, the result is the same. We belong. Not by entitlement, but by emergence. Not because we were meant to be here, but because here is the only place we could have become what we are. And maybe that belonging is more powerful than purpose. Because purpose can be questioned. But belonging is felt. In your bones. In your breath. In your silence under the stars. So when you ask, is the world for me? Also ask, am I for it? Am I here to take or to tend? To dominate or to dwell? To conquer or to complete the circle? Because maybe the deeper truth is this. You are not separate from the world. You are its voice, its eyes, its hands, its memory. You are not the audience. You are the echo, and you've always belonged. Let's return to the question that started all of this. Was Earth designed? When you stack it all up, the timing, the chemistry, the rhythms, the beauty, the balance, it almost feels intentional. Like a system built not just to exist, but to support, sustain, and evolve life. But here's the tension. Intent is not the same as inevitability. And complexity is not the same as design. So which is it? Was Earth crafted like an artifact? Or did we simply discover a place where the rules of nature happen to make life possible? Let's look at what we know. Science shows us random mutations shaped evolution. Gravity and chemistry shaped the planet. Cosmic events shape time and space. Our minds are pattern-seeking, storytelling engines. So we see meaning because we're built to. We connect dots even when there's no artist behind them. And yet, there's also a truth beyond test tubes and equations. This world feels ordered. It resonates. It fits. The constants of physics don't feel arbitrary. The elements of life don't feel accidental. Even chaos, when viewed at scale, starts to reveal structure. So maybe the real answer isn't binary. Maybe design and discovery are not opposites. Maybe the universe wasn't built for life, but life emerges wherever the universe allows. And in doing so, gives the universe a witness. Maybe we discovered a world that seems designed, not because it was created for us, but because life adapts so precisely, it makes its home feel like a palace. A spiderweb fits its branches. A beehive fits its hive. A brain fits its skull. None of these were placed. They grew. They settled. They belong. And maybe the same is true for us. Earth isn't a gift wrapped in atmosphere. It's a partnership. We didn't just find a world that fit us. We became a species that fits this world. So, was Earth designed? That's a question only your wonder can answer. But one thing is certain. You are standing in the rarest of places. A world that works, that holds, that breathes, that sings. Whether by fate or physics, you are here. And that's enough to make it sacred. From far away, from Saturn perhaps or the edge of the solar system, Earth looks like a pale blue dot. Small, fragile, almost invisible. And yet, on that dot, every tree, every river, every love, every song, every hope, every story we've ever told has taken place. It's humbling, it's breathtaking, and it's a reminder of just how rare this all is. Let's retrace what it took to make that dot possible. A universe that expanded just fast enough not to collapse. Stars that lived and died to create heavier elements. A planet formed at the right distance with the right mass, atmosphere, chemistry. A moon that steadies it. Water that flows. Soil that breathes. DNA that remembers. Organisms that adapt. Minds that awaken. Intelligence that builds. Consciousness that wonders. Each step could have failed. Many nearly did. And yet, they didn't. We don't know if Earth is unique. We hope not. Because if life exists only here, then its value is beyond calculation. But even if there are other living worlds, countless ones, this one is still ours. The one that gave us our first breath, our first questions, our first glimpse of the stars. You are not separate from that. You're not standing on Earth. You are Earth. Its atoms, its patterns, its awareness, its memory. You are the part that looks back, that writes, that records, that carries. You are the witness and the continuation. So as we reach the end of this journey, the question isn't, was Earth designed? The question is, what will you do with the gift of existing here? On this dot, at this moment, against all odds. Will you protect it? Will you explore it? Will you wonder at it again and again? Because you were given something rare. Not a guarantee, not a promise, but a pale, perfect chance. And that might be more precious than any design.